to limit the temperature increase to 1.5 degrees Celsius above pre-industrial level. Now we have the limit. This Paris Agreement actually gave us the limit that we need to. We do not need to let the temperature, global temperature of the Earth, to exceed the value of 1.5 degrees Celsius. Now, why all the stress on 1.5 degrees? That's because the United Nations Intergovernmental Panel on the Climate Change indicates that crossing the 1.5 degrees Celsius threshold would set free far more severe climate change impacts, including more frequent and more severe droughts, heat waves, and rainfall. We are already hating the consequences. We are already being affected by all of these severe weather phenomena. So later on, after the temperature threshold would exceed the 1.5 degree Celsius value above pre-industrial pre-industrial level, it would be very, very, very difficult to turn back. Now, related to these this legal binding, or related to Paris Agreement, two concepts were devised, or two concepts were given in order to not uh, pass or increase, in order to not to pass a threshold of 1.5 degrees centigrade. One is carbon neutrality and other is net zero. Now, carbon neutrality is a term that refers to balancing out the total amount of carbon emissions. Okay, that means that anthropogenic carbon dioxide emissions of a subject, of an organization, or of a business, or whatever is producing that carbon dioxide anthropogenically, is also removed in the same amount. That is, anthropogenic carbon dioxide emissions should be balanced by the removal of anthropogenic removal of carbon dioxide. Now, the other term is net zero. That refers to the amount of greenhouse gases such as carbon dioxide, methane, sulfur dioxide that are removed from the atmosphere being equal to those emitted by the human activity. So both of these concepts are referring to what, that the anthropogenic activities that are increasing the amount of carbon dioxide and that are increasing the amount of greenhouse gases, both should be neutralized or compensated anthropogenically. That is, that should be compensated by the same sources that are releasing these gases. Okay. Now, all of these concerns, the Paris Agreement and this concept of carbon neutrality and net zero, are not baseless, all right? They are based on scientific studies, they are based on scientific facts. Here on your screens, you can look at a plot that how much of a carbon dioxide has been released into the atmosphere and is still present, which is not mitigated or is not used by the sinks. As you can see that years before today, for millennia, for many, many, many millions of years ago, atmospheric carbon dioxide never uh, 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 went beyond the limit. As you can see, this dotted line of 320, below the 320 ppm level. But today, that is in 2024, that graph is of 2023, this limit exceed exponentially, this limit exceed very, in a very, very, very fast manner, and it is continuously increasing. Now look at these two plots. The first one shows how much of a Greenland glacier mass is being affected or changed. The mass is rapidly, as the plot see, the mass is rapidly decreasing uh, per year. The amount is very high. You can see that it is 269 gigatons per year. So, and this plot is up to the year 2022, and this rapid decrease in the glaciers, rapid decrease in the ice masses because of the global warming, obviously, because the ice is melting rapidly. In the second plot, you can see that the second plot, you can see the rise in temperature, how much the temperature, global average temperature, is being rise by the anthropogenic activities. So you can see that all of these plots of all of this data, all of everything that is that we are stressing, that United Nation or the every international body is stressing, that all of these things are not baseless. The climate change is occurring. The climate change is based on the scientific fact, and you can also observe that sea level rise, the changing rain pattern that we observe in our countries or in our cities, also the extreme weather events like extreme heat waves, and we also are getting the cold waves. So this is the proof that climate change is real, and it needs to be mitigated with the help of what? Net carbon zero or net zero and the carbon neutrality. Now, here's a diagram showing that how the concept of net zero would help us. Now, this is the current situation. As you can see, lithosphere is what where we are living, the surface of the earth, and we have the land and ocean biosphere, obviously, and the atmosphere. Now, current situation is what we are releasing the carbon dioxide or the carbon or many GHGs into the atmosphere, from the lithosphere into the atmosphere, and also the land and the ocean biosphere are also obviously releasing the amount of carbon, amount of many other gases, obviously because living organisms are present there naturally. They also emit all these gases, but in a very minute amount. But the land and the ocean biosphere also act as a sink. Sink is what? That they are also absorbing or utilizing the carbon or all those greenhouse gases released into the atmosphere. So to balance the whole ratio of the, for example, carbon dioxide. But the current situation, as you can see, the thickness of the arrows, that the amount of the emissions from, for example, fossil fuels or the industrial processes from the lithosphere, that is from the anthropogenic activities, is going into the atmosphere. The thickness of the arrow is very thick. That means that large amount of emissions are contributing to this whole greenhouse gas emissions. And on the other hand, you can see that a very large amount of obviously gases are being released by the lands and by the ocean biosphere. And the sink, the arrow where it is written the sink from the land use change, as you can see that it is very thin. The current situation, it this whole figure depicts actually that we are releasing large amount of gases into the atmosphere in such a way that the sinks, the natural sinks of the earth, are not able to fully capture all of those emissions. This is the current situation. Okay. Then we have, if we get sorry, this slide is actually, let me just correct it. Okay, now next is obviously what? Sorry, the previous slide was what was natural. Now the current situation is, as you can see, the thickness of the arrows is further has further thinned. That is, the sinks present on the lithosphere, the sinks present on the land, the sinks, the carbon dioxide or the greenhouse gas sinks present in the ocean biospheres are now even not being unable to fully, not only fully, but they are also not they are not even able to capture 50% of the emissions into their systems, and they are not able to utilize even 50% of the emissions from the fossil fuel, the emissions from the industrial activities. into themselves, that means that the amount released into the atmosphere is obviously present in the atmosphere. It is not being utilized by the natural sinks of the nature or natural sinks of the earth. For example, the ocean has ability to capture carbon dioxide, and this carbon dioxide is used by the phytoplanktons present in the oceans to produce food, obviously to produce oxygen. You must be aware that oceans are a huge source of fresh oxygen. So it acts as a carbon dioxide sink. So the amount we are releasing, the amount of carbon dioxide we're releasing into the atmosphere is very large as compared to how much the earth can mitigate. And in case of durable net zero, obviously the anthropogenic carbon flows in and out of each spheres would be balanced. Net zero is what? That the lithosphere, which was originally only generating the emissions, only generating the carbon dioxide, would also be able to act at a sink. For example, we should develop net zero concept of net zero, as I already mentioned, that it involves that the anthropogenic emissions that are being released into atmosphere should be mitigated by the similar sources. So that means the lithosphere that is producing, lithosphere where we are producing, where we are living through our activities, like for example carbon dioxide, should also uh, uh, produce some technologies or utilize this produced carbon dioxide in a way that we are also acting as a sink for that particular carbon dioxide in order to minimize the amount of the carbon dioxide pushed into the atmosphere. So this is how the net zero concept would help. Now, the Paris Agreement obviously is not only giving us just the order to just do this, do that, and you need to just mitigate the amount of carbon dioxide. You need to achieve the concept of net zero. You have to get the carbon neutrality. No, it is also actually providing us a framework based on what? Best available science. The Paris Agreement works on a 5-year cycle of increasing ambitious climate action. Now, since 2020, many countries have been submitting their national climate action plans, which are known as NDCs, that is, nationally determined contribution. And in their NDCs, countries are actually communicating that what action that they want to take, what feasible action that they will take to reduce their own greenhouse gas emission. And the Paris Agreement is obviously providing a framework for three important pillars. One is financial, second is technical, and third is capacity building. Now, the Paris Agreement is doing what? It reaffirms that developed countries, those rich countries like USA, like China, like countries of the European Union, they should provide financial assistance to developing or underdeveloped countries. Obviously, climate finance is needed for mitigation because large scale investments are required to significantly reduce the emissions, right? So, those countries who are not able to do so because they are poor or they do not have any infrastructure, they do not have, for example, in case of technical support, the developed nations Paris Agreement makes it mandatory for the developing, or it urges them to give them support either in a form of finances or either in a form of technology. Also, not all developing countries have sufficient capacities to deal with many of the challenges brought by the climate change. For example, our country, for example, Pakistan, it do not have much capacity to deal with. As you can see, that we are facing consequences of like drought, we are facing the consequences of flood. So we do not have specific capacity to mitigate or even to face all these challenges. So, as a result, the Paris Agreement places great emphasis on the climate related capacity building for developing countries and request or urge all the developed countries to enhance support for capacity building actions in the developing countries. Now, let's discuss some of the action plans given or put forward by the countries, or like we have an action plan for the GHG mitigation or net zero, for example, by the European Union. Now, there the small scale plan from the year 2021 to 2023 includes reduction of the emission, and this plan was adopted in 2023, and they are actually making proposals to make the European Union's climate, their energy, their transport, their taxation policies fit in a way that they would help reduction in the greenhouse gas emission by at least 55% by the 2030. That is a decade. It is a plan that is based on the 10 years. And what are they comparing it with? They are comparing it with their 1990s level. Now, this target or this plan of the European Union would enable the European Union to become the first climate neutral continent by 2050. That is their main goal. And they are changing their governance system. They are forthing their many regulations, many legal requirements on the government level. For example, for governance on the energy union and climate action, they are adopting many integrated rules to ensure that they are planning, they are properly monitoring, and they are reporting their progress towards this 2030 climate energy targets and its international commitments under the Paris Agreement. And obviously, involvement of citizens and all of the stakeholders is important. So they are also emphasizing on involving their citizens, involving all the stakeholders for their goal. Next is their long-term strategies. That is, the previous one was up to 2030, and then their European Union's long-term strategy is up to the year 2050. And they aim to be climate neutral, completely climate neutral by 2050. And this objective is actually at the heart of the European Green Deal. And it is a legal binding target thanks to the European, obviously, climate law. And they have developed many strategies. Like, for example, they are making strategies that should be consistent with the member state integrated national energy and climate plan, that is NECPS, for the period 2021 to 2030. They are making sure their short-term target that we previously discussed should be and their long-term target, they should be consistent with each other. And obviously, they require the member states who are included in this whole strategy. They are in urging their member states to submit their national long-term strategies to the Commission. And okay, now previously they have urged, or they have developed a meeting there where they discussed and submitted their first national long-term strategies in 2020, year 2020, in the month January, and the next strategies will be discussed in the year 2029. That means that every 10 years they will be discussing that how much they have achieved in their regarding their strategy in achieving a climate neutrality or carbon neutrality, and how they are planning to further go for the strategies, different strategies, that how different strategies should be maintained or given in the terms of finances, in terms of their technical support. They will be discussing this every 10 years. Now, this is a chart that is discussing, or that is giving us that how much progress is made in by European Union in cutting their emissions. And as you can see that European Union hard work has really helped them reach a reduction in the level of the carbon dioxide. You can observe the European Union slowly decreased its greenhouse gas emissions since 1990s, as already mentioned, that they are comparing their activities to that of their 1990s, that how much emission they are reducing, how much emission they were releasing in 1990s, and how much they will be reducing now. So they have reached a total of 32.5% in 2020, and the COVID lockdown actually in 2020 caused a fall in emission, as you can see here. It caused our downfall. But then, obviously, when the lockdown ended, a strong rebound can be seen in 2021 here. Next, 2022 emission is obviously has decreased, as you can see in the plot. Now, the dotted red line here, you can see dotted red, or the pink line you can see, is actually the is the aim of the European Union. It was the aim that they would reach this amount of carbon neutrality by year 2030 and by the year 2050. But the blue dotted line is actually the projection by the member state, and as from that you can see the European Union is currently not on track to reach its 2030 objective of removing about 310 million tons of carbon dioxide from the atmosphere per year. So they plan on stepping up their game, and they are fastening their implementation efforts. Now, related to this, there is a financial alliance known as Glasgow Financial Alliance for the Net Zero, also called as GFANZ. You can see that this financial alliance help acceleration to the transition to a net zero global economy. It's actually a global coalition, and it is working to develop tools and methodologies that are required to turn the financial institutions' net zero commitments into action. And it includes net zero asset manager initiatives, the United Nations convened net zero asset owner alliances, the newly launched net zero banking alliances. So over about 160 firms are allied in this Glasgow Financial Alliance, and they have joined forces. And the common goal is what? Obviously, steer the global economy towards net zero emissions and deliver the Paris Agreement goals. The Glasgow Financial Alliance for the Net Zero, this is actually chaired by the United Nations Special Envoy on the Climate Action and Finance, called Mark Carney. And he is actually bringing together leading net zero initiatives from across the financial system to accelerate or fasten the transition. And the members obviously include very rich people, the assets owners, the manager, the banks, who has the power to mobilize the trillions of dollars or billions of dollars behind the transition to net zero. Obviously, as I've already discussed, the finances are very important to reach this goal of net zero, to reach the goal of carbon neutrality. So this Glasgow Financial Alliance is actually working on that, providing finances. Now, I've been discussing carbon neutrality, net zero, and climate neutrality. These are, although these three terms or these two terms are related, are interlinked, but they have slight differences. Carbon neutrality actually refers to only carbon emissions, okay? And it involves national mitigation policies and involves, okay, like offsets, etc. And the net zero in refers to all the GHGs, all the greenhouse gases, not only carbon dioxide, but also the methanes, the fluorides, the water vapors, everything, okay? And the net zero emissions have offsets in the same country. Now, the concept of climate neutrality is what? Reduction of all the GH to a point of zero. Carbon neutrality is related to only carbon. Net zero emissions is related to all the GHGs. And the climate neutrality is you have to reduce all greenhouse gases to the point zero, and it involves the use of natural sinks and also elimination of all the other negative environmental aspects. So you can see that all of these are interlinked, all of these are related, and without one another, without one, the other won't be able to make much sense, but they are different. Now, similarly, related to this, we have the three scopes of the emissions, that is scope 1, scope 2, scope 3. We have already discussed in the previous session. Just to remind you that scope 1 includes the direct emissions, like the emissions from the sources that an organization owns. Like, for example, if an organization is burning fuel for its energy purposes, or uh, to carry out the processes or to carry out the services it is providing, that would be included in the scope 1 emissions. The scope 2 are the indirect emissions that company causes indirectly, that comes from where the energy it purchases. Actually, scope 2 emissions are not released by the organization or the business or the firm itself, but it's actually the emissions that is being released because the firm is providing its services. For example, the firm needs electricity to run its processes, to run, for example, its boilers, or to run its conveyor belt, or to run the whole facility. So obviously, where this energy or the electricity is coming from the burning of fossil fuel, from the burning of coal, etc., right? So these are the major sources of electricity. So scope 2 involves the emissions that are being released indirectly by the firm because it is using the electricity produced from the non-renewable sources, or with high emission factors. And the scope 3 also include the indirect emission, but they are actually created in the company's value chain. For example, when a company is buying a product, using a product, or disposing the product from its supplier, so how and where the suppliers are getting those products, those services, or those things that company is buying it, obviously they are made, or obviously they are extracted by using a lot of energy, hence producing lot of emissions. So that is where the scope 3 emissions come from. That is, a firm is using, for example, a raw material, a metal. So how much emissions the metal process of metal extraction, metal excavation, metal transportations are releasing are included in the scope 3. Now, related to these scope 1, scope 2, and scope 3, we have a concept known as GHG accounted, that is greenhouse gas accounted, and which is actually also called as, often, because obviously carbon dioxide is a major greenhouse gas emission, so we major greenhouse gas, right? So it is often referred to as carbon accounting as well, and it is actually the process of measuring the amount of greenhouse gas emissions a company, organization, a business, or a firm is producing. It is a way that companies can measure, obviously, their how much their activities are releasing carbon dioxide or other greenhouse gases into the atmosphere. And it is useful because various that it is useful because the organizations or potential investors or stakeholders can calculate and can know that they how much emissions they are responsible for, and how much of the carbon credits, that is, carbon credit is a term that is that defines actually how much carbon an organization is allowed to emit. So they can, by the help of GHG accounting or carbon accounting, they can realize that how much their processes are releasing carbon dioxide or other greenhouse gases, and how much they need to put a hold on that, how much they are allowed to release and how much they need to mitigate or need to use in other purposes, so as they are not released into the atmosphere. And many in the developed nation, for example in US and in European nations, in the countries of the European Union, they have made it mandatory that the organizations or companies required to disclose at least some of their emissions with the help of this GHG accounting. Now, a greenhouse gas, obviously, when we are discussing the greenhouse gases, and that we are discussing that, then the organization need to know that how much they are releasing. So they need to develop obviously GHG inventories. So the GHG inventory is actually a list of emission sources and the associated emissions quantified using standard methods. The purpose of developing this inventory is managing GHG or greenhouse gas risk and identifying the reduction opportunities, that how they can reduce uh, those greenhouse gases that they are producing. They can also, with the help of this inventory, participate in voluntary or mandatory GHG programs all over the world, and they can also participate in the greenhouse gas market. And this process actually consists this making an inventory development process actually consists of four major steps, as you can see on the screen. First is review accounting standards and methods. The organization need to determine that their operation boundaries, what are the operation boundaries, and they have to choose a base year. Like for example, the goal that European Union developed, that they need to develop, they made strategy that their carbon emissions should be well below the levels that were in 1990s, right? So a company, to make a company, an organization, in order to make a GHG inventory, they need to choose a base year from where to start, okay? And obviously for that, a third party verification is necessary. Then data collection comes, that what type of data they need, what type of method they need, depending on their activities, depending upon what product that organization is making. Then they would obviously develop procedures, tools, and guidance tool, and they would compile the whole data, right? They would develop the procedures, they would develop the methods, and then they will compile and review after the collection of the data. For example, what type of electricity they are using, how the electricity is reaching, what type of natural gas they're using, etc. Okay, and then obviously they would estimate that what or how much data they lack, that how much data is missing, and they would obviously calculate the emissions. Here is the process. They would calculate the emissions by the formula that I'm going to discuss in the next slide. The third step is develop a GHG inventory management plan. Here, the formalized data collection procedure, the company would do what? They would formalize the data collection procedures or document the processes. They would what? They would document each and everything. Obviously, the data they collected, the type of data missing, and how they're gonna use, then how the inventory data would be managed. They need to document it. And here is the step number 3 is where they would make an inventory management plan, a proper plan, that how they can manage their whole inventory, that how they can manage that how much emissions they are releasing in a quantified terms. And the next and the final step is setting a GHG emission reduction target, and obviously tracking and monitoring, that they have to develop a target, that how much emission they need to decrease. First, they have established in the step number 1, 2, and 3 that they are releasing this much, for example, carbon dioxide. And in this, and they have then developed the methods to collect data, to calculate how much they are emitting and how they are emitting, what are the sources. And in the final process, that step number 4, they need to set a reduction target, that how much they need to reduce the emission. And then they would track their activities, that where those emissions can be stopped, where where in the process of whole where in the whole supply chain management, where they can reduce the amount of emission. And they would track and then obviously prepare reports related to their target and related to their progresses. Now, this is how you need to calculate the emissions. Now, number 1 is a step is what? Calculate the emissions from each GHG. Obviously, a company organization is not releasing only single GHG, right? So there are various GHGs or various greenhouse gases emitted by the organizations. So first they need to calculate, an organization need to calculate the emission from each GHG. Either it is methane, either it is water vapor, either it is sulfides, either it is NOx, that is nitrous oxide or oxides of nitrogens, etc. So how they would calculate the emission is what? Activity multiplied by the emission factor. The unit of emission factor is tons of the gas per activity unit. Now, actually, activity is what? For example, a company or organization is burning fossil fuel release because due to fossil fuel release into the atmosphere, and the amount of each gas released per unit of the activity. For example, ton of the for example, a company is using coal to produce energy. So, how much ton, or how many tons of the coals are burned, are is referred to as emission factors. Okay, the activity, that is the activity that the organization is performing, multiplied by the emission factor, that is the amount of that particular fossil fuel, amount of in tons of that particular fossil fuel, or the source of the greenhouse gas per activity. For example, coal is being burned. For example, 1 kiloton of coal is being burned to produce this much of electricity. That would be the emission factor. Okay, multiplying these two terms would get us the amount of emissions in tons. Okay, the next step is calculation of the carbon dioxide equivalent for each GHG and some overall emissions. Now, the carbon dioxide equivalent is what? The number of metric tons of the carbon dioxide emission with the same global warming potential as 1 metric ton of another greenhouse gas. Actually, here, with the concept of carbon dioxide equivalents, we are equalizing the effects of other GHGs, effect of other greenhouse gases, with that of the carbon dioxide. So here we are actually doing what? We are just creating a standard, a sort of standard, that this much of the carbon dioxide produces this much of effect. So how much and other greenhouse gas would cause the same effect as that of this much of the carbon dioxide. So we are creating a single standard of that, equalizing other greenhouse gases to that of the effect of the carbon dioxide. So in order to calculate the equivalency, we would obviously multiply the emissions that we calculated in the step number 1 with the global warming potential, GWP. That would give us the total emissions in carbon dioxide equivalency. Now, the term global warming potential is actually is a standard terms. Okay, now in the table below you can see that the global warming potential of different greenhouse gas emissions is standardized, are given, they have a particular value. For example, the value of GWP for the carbon dioxide is 1, for methane it is 25, for nitrous oxide it is 298, for hydrofluorocarbons it is 12 to 14 for up about 15,000, etc. Now, depending on the situation, depending on the company's other situation, this value can be calculated through various formulas, but most organizations use this the standard values. Now, obviously, we have determined that why the concept of the climate change and net zero is essential, and how to calculate the GHG emissions from the activities of your organization, your businesses. Next would be the mitigation, right? Because obviously the end goal is mitigating this whole effects, mitigating the effects of all these emissions, right? This is our final goal. So in order to mitigate the effect, mitigate the concept of decarbonization is essential, but the clock is ticking. Delay is detrimental because we have already reached a very dangerous level. Now, the common steps your organization can take to decarbonize itself would be obviously turn pledges into action, because Only talking would not reduce the amount of carbon dioxide or would reduce the effects of the carbon dioxide, right? So we have to turn the pledges, we have to turn our statements into action. The second one is the developing a working strategy. Obviously, doing anything without a working strategy is useless, right? So the organization needs to develop a strategy, and then based on that strategy, it should create a flexible and adaptable roadmap for the future. For example, if the company of your organization is developing a strategy to decrease or to decarbonize itself up to some extent, so obviously it would need to develop step by step roadmap, that at step number one it would do this, at step number two it would do this, in order to and at a given, and give a target here. For example, like about at that about that it should reach this amount of decarbonization limit by the year 2030, for example, or by the year 2050. So a roadmap that which is adaptable and flexible is needed in order to decarbonize itself. The organization needs. Now, for example, according to a World Economic Forum, if you want to decarbonize, for example, you want to decarbonize your city, or a mayor want to decarbonize the city, following steps, the following roadmap or flexible roadmap or a strategy can be followed. Number one is develop a baseline, targets, and obviously the roadmap. They should be data driven. We cannot plan on theoretical net zero future dependent on the wishful thinking, just a wishful thinking that the behavior of the people would change, so this would happen, this would happen. No, the baseline, the targets, the roadmap that it needs to develop, the mayor need to develop, you need to develop to decarbonize, for example, your city. It should be based on the data. It should be based on the scientific data or the factual information. All right, wishful thinking are not necessary or are useless here. Okay. After development of the roadmap or a baseline target, you need to establish education programs and net zero steering committee. Like, it should be diverse, cross discipline, cross industry group focusing on all aspect of the decarbonization. Okay. And it should provide direction on integration with national plans and system, that all of the steps, the educational programs should integrate. They should involve, first of all, they should involve each and every sector of the city. It should involve every industry present in the city. It should involve every enterprise present in the city. And the education program should be made in a way that it is integrated or it is related with the national plans and the national system. Third, you need to, or the mayor need to understand your city as a system within a system. Because system within a system means that this you cannot do this overall in a broader way. You need to take each and every aspect. We need to take, as I already mentioned, that the in order to establish the educational program, it need to consider each and every industry. It needs to consider each and every enterprise in the city. So you need to understand that your city is not one system. It is actually the system within a system. So involve each and every stakeholder, involve each and every process happening inside the city, each and every the use or utilize each and every source present in the city. Do not over rely on the grid scale energy decarbonization. Over reliance on anything, over reliance on for example, grid scale energy decarbonization, no, do not over rely. You need to consider other factors as well. Just not consider that grid scale energy decarbonization would be enough to decarbonize your city. No, you need to consider other aspects as well. Fifth, you have to ensure your pathway delivers climate resilience. Cities are becoming obviously increasing susceptible to climate change, right? So cities must focus, or you must focus, the mayor who aims to decarbonize the city, he should focus on ensuring the built and the natural environment are not only resilient but also adaptive. For example, we see in Pakistan that the amount of rainfall, for instance, is different each and every year. The season where the rain occurs is different each and every year. The weather patterns are shifting, right? So you have to ensure that your pathway that you are developing to decarbonize your city should be climate resilience. It should be adaptive, that it should be made, for example, the infrastructures of the city, or the usage, the buildings or the processes they are utilizing in the city should be climate resilience. They should not be highly affected by the ever changing climate of the area. Then you have to green your aging infrastructure. That is, do not demolish or remove the old infrastructure. Obviously, because building an infrastructure, creating infrastructure takes times, money, and obviously carbon, right? So repurpose your aging infrastructure to create new urban green spaces and pedestrian transport links. Then you need to adopt a multimodal view of the future of the transport. For instance, when the COVID occurred, COVID came forth in 2019 and then 2020, it had impact. The impact of it presented different challenges, right? For example, the people were not able to travel very much. They had to, the lockdown urged the citizen to remain in their house, do their jobs, but by remaining in their house. Okay, so it built suitable trust. For instance, many digital infrastructures was established that way. For example, I remember that in Pakistan, uh, prior to the this COVID scenario, online deliveries or online education systems were not fully developed, were not actually developed at all. But after COVID, these digital infrastructures were developed. Many digital platforms were created where the people, without the need to commute to a place, they did their work sitting at their homes, sitting at their rooms. So obviously this helped decreasing the amount of carbon dioxide release into the atmosphere, right? So you have to adopt a multimodal view of the future transport, that you need to develop the infrastructures that would decrease the need for the commute. Okay, and obviously don't forget the residuals. Obviously the plan isn't foolproof. Yeah, you would definitely need more time to fully decarbonize, or maybe you won't be able to fully decarbonize your city, right? So there's always a possibility. So don't forget the residuals, the amount of remaining carbon dioxide or remaining carbon sources, carbon emission sources in the city. You have to make credible plans for them. You have to develop technologies, for example, like carbon sequestration, for example, to capture the residuals as well. And obviously, all of it is not possible without investment, and to attract the investment you need a credible plan, a good understanding of the risk and its mitigation. Obviously, the sustained government policy supporting that is supporting that return on investment, and progressive and collaborative uh, uh, finances etc are necessary to be considered. Because in order to attract finances, you need to give a full plan. You need to show the investors that you understand the consequences, that you understand the overall concept of decarbonizing your city. And obviously they would want their profits, their return of their finances in the form of profit or in the form of lump sum, obviously. So you need to uh, develop a strategy to attract sustainable finance. There is another a term or a coalition or charity or a framework that is called Science Based Target, SBT. This is a framework for the corporate net zero target setting in line with the climate science. Now, it's actually a charity, and the partners that are included or that are working in this charity includes the Carbon Disclosure Project, that is CDP, UN's Global Compact, Women Business Coalition, World Resource Institute, and the Worldwide Fund for the Nature, that is WWF. They all are working together to create science-based targets to provide clear, consistent, and science-based definition of the net zero. They are actually giving us standards uh, uh, by which the companies can set science-based net zero targets to demonstrate their climate action leadership and their commitment to ensuring habitable planet for all. That is, without, obviously, I have already mentioned previously that baseless assumptions are not are actually useless here, right? You have to give scientific reasoning for each and every step, because climate change overall is a phenomena that is proven by the science, right? So you need to develop strategies, you need to develop targets based on science. So this science-based target is actually a charity or a framework uh, developed by the cooperation of many different, as I already mentioned, the different partners are working together to give scientific definitions, scientific reasoning behind the concept of net zero, so that the companies can also set their science-based net zero targets. And the process to set the science-based targets according to SBTi's recommendation include these five processes. First, you have to select a base year. Companies, organizations, entrepreneurs, or the firms, they need to establish a base year to track emission performance consistent and meaningfully over the target period. Okay, now the companies should be aware that scope 1, 2, 3 emission data should be accurate and verifiable. Okay, and the base year should be representative of the company's typical profile. Okay, as I already mentioned, the European Union developed their mitigation plan, and they selected 1990s as the base year. All right. So a company need to set a base year from which they need to calculate that how much of a scope 1, 2, 3 emission data, and how much they need to mitigate, or how much they need to minimize their emissions. Then obviously they would calculate their company's emissions by the formulas that I have already discussed, and then they will set the target boundaries. Near-term science-based target boundaries obviously would include scope 1, 2, 3. Near-term must, like for example, a 10-year boundary, a 10-year target boundary, uh, that in within the 10-year, the company needs to mitigate or reduce the emission by this amount. Okay, and then they would also develop a target boundary for a long term as well, that in 20 years or in 50 years, they need to develop methodologies or ways to mitigate or decrease the amount of emissions by the year, for example, 2050, or by the year, for example, 2040. Then obviously they would, after the setting of the target boundaries, the amount of emission, they would choose a target here, that from this year to this year, I have already mentioned that they have to select a base year. For example, they are selecting 2015 as a base year, so the target area would be, for instance, 2030, that till 2030 they need to develop methodologies or science based methodologies uh, to reach this amount of decrease in emission, or this amount of carbon neutrality, like 50% or by 40% by this year, by the end of this year. So selection of the starting year and the selection of the ending years. And then obviously they would calculate their targets repeatedly and continuously, that how much they have achieved throughout the years, how much is remaining. Now, how to reduce scope 3 emissions? Scope 3 emissions obviously are indirect emissions, and it is difficult to calculate the amount of the scope 3 emissions, and to obviously to devise methodology to reduce, because scope 3 emissions obviously include those emissions that are released due to, or the emitted due to, the activities or by the using of the services of that company, right? So it is difficult. So how would you calculate or assess the emissions of the scope 3? These are the three main methods. First is obviously LCA, that is life cycle assessment. You would consider raw material, the extraction, the production, the transportation, product use, and end of life disposal, right? The second is emission factors and conversion coefficients. That is, this method is useful when the detailed data is not available. That is detailed data that how much energy was required, or how much emissions were released during the extraction process, how much the amount of carbon dioxide or methane was released, for example, during the usage of that product. So you would when direct data is not available, you would use the emission factors and the conversion coefficients that relevant to your specific industry to estimate the emission from various sources. These are actually standardized amounts given by various organizations depending upon the activity of the organization. The third one is data analytics and technology. Obviously, you can use advanced data analytics and technology solutions to process large data sets and enhance the accuracy of the emissions measurement, like real-time data monitoring, real-time data analysis tools that you can find. You can find the experts there. You will have more by using this. Obviously, you will be able to make more informed decisions and proactive emission management. And uh, in order to do so, in order to assess the scope 3 and in order to reduce the scope 3 emission, you need to keep in mind that you have to establish a benchmark. Okay, benchmarking against industry standards would allow you to make comparison that how much you have room to improve, and how much realistically you can reduce, or you can assume that how realistically you can make targets for the removal of the emissions. So benchmarking is essential. Now, to reduce scope 3, following steps can be taken by the organization or by the supplier. First is prioritize the scope 3 emissions. Indirect greenhouse gas emissions from the suppliers and the products sold, obviously, as I already mentioned, includes in the scope 3. Recognizing and addressing them is critical. While many firms are actually seriously measuring their direct emissions, scope 1 emissions, they're also measuring their scope 2 emissions as well, because they are easy to calculate. The scope 3 emissions are neglected. Okay, so you have to prioritize the scope 3 emissions, number one, in order to reduce it. Okay, the second is harness the power of procurement, that what type of services and products the organization is getting, how they are getting, from where they are getting. This involves obviously supply chain optimization, that throughout the supply chain, what is the design of the product, what is the life cycle, how much energy efficient the product or the raw material is, how much energy is released or the emissions are released by transportation and logistics. Next, obviously, you have to consider the employee engagement. This is a very important step. You have to observe how the employees of the organization, of the business, are engaging in this whole process, how their behavior would change, how they are prioritizing the concept of net zero or concept of neutrality. Also, establishing a cross-industry supply milestone is necessary. That is, by joining forces with different industries, by different collaboration with different organizations, you can amplify the impact and motivate a broad range of suppliers, okay, in order to reduce the scope 3 emissions. And the final and the most important step is measurement and reporting. You have to measure how much target you have achieved. You have to measure how much um, amount you have, how much target you have achieved, and how much is still remains, and how you can work on mitigating or minimizing the remaining targets. And obviously you have to report it to the stakeholders, to every stakeholders, to the local community or to the international community, and obviously to the governments, to your suppliers and everyone. Now, it is already established, we have already established that climate change is an anthropogenic climate change is anthropogenic. That is, it is caused by us, right? Because of the human activity. And the the major cause is increasing combustion of the fossil fuel to cover the growing need of energy. So the decarbonization of the energy sector has been, obviously, because since the concept came forward, obviously many, especially the energy sector is researching on various ways to decarbonize their source of energy for several years. And they have reached a conclusion that the most obvious way to achieve decarbonization is the use of renewable energy, right? So therefore, many countries already use a continuously increasing share of their renewable sources. As you can see in the graph, that the carbon dioxide emission by different countries, how much carbon dioxide different countries have released because they have been using non-renewable sources. And for example, like in their transportation, in their businesses, in the organization, right? So the most obvious solution they have come forward with is that they have to shift from burning of fossil fuel to the use of renewable energy. So many countries are increasing their share of renewable sources such as wind energy, solar energy, geothermal or hydro energy to generate electricity. For example, Paraguay has shifted 99% onto renewable energy. Norway has shifted 97%. Costa Rica to 93%. China and USA had the highest installed wind energy and solar photovoltaic capacity worldwide in 2019. So the most common and comparatively easiest way to shift to decarbonize your city, to decarbonize globally, is to shift to renewable energy. Now, obviously, challenges are present, right? Nothing comes at a fair and right price. The ride towards the goal of decarbonization would too not be smooth. So there are many challenges that need to be overcome in order to fully decarbonize the whole globally or nationally. Number one is the challenge of environment sustainability. Are the new technologies that are being developed are environmental stable? Are they sustainable? The raw material you are extracting to develop those renewable energy sources is sustainable? Are you uh, uh, exploiting the raw material? The process of manufacturing, for example, of photovoltaics, obviously involves various different processes, right? So are all those processes sustainable? Are all those processes environmental friendly? So this is actually a concern. Then obviously comes most important challenge is investment. New systems obviously require investment, but uh, there has been no incentives to develop a sustainable energy sector since there's no monetary reward. For a decarbonized energy sector, new investments, obviously, as I already mentioned, are necessary. So investment in the energy sector is actually investment. When you invest in the energy sector, it is a long-term decision, right? Because development of the energy sources involves long duration of the time, and obviously when this energy source is put to work or is given to the people, some people would obviously not accept it. It is difficult to change the whole infrastructure. So it's a long-term decision process. It's long-term process. So the investors are reluctant to invest in this whole energy conversion system, obviously, because when you are going to shift from fossil fuel to, for example, hydropower plant, you would need investment, and this whole shifting would obviously has many concerns. So you have to, in order to attract the investors, you have to uh, fully elaborate, you have to develop good policies in order to attract the investors, in order to ensure them that their investment would not uh, go to waste. Then obviously with renewables come the security of the electric supply, because the electricity generation from the renewable sources is intermittent, right? It cannot easily adapt on the demand fluctuation. For example, if you're using a hydropower plant and a country is facing drought, so the whole supply, this whole supply would be obviously would be affected, right? Or in case of flooding, the hydropower plant supply would be affected. Same is the case with solar energy. If a country is facing, for example, long periods of weather patterns in which it is not able to harness the solar energy completely, so this whole supply of electricity with the help of solar plant would not be efficient, or would not be quite would not be efficient, or it would not be sufficient for the whole supply chain. Okay, so the renewable source of energy is intermittent. Okay, next is obviously economic stability. A fair transition must consider the changes in economic structure. Obviously, a country, as I already mentioned at the start of this session, that the Paris Agreement actually urges the developed nations to help financially, financially to the developed or developing countries, or the third world countries, financially, to develop the infrastructure or to develop the technology, right? So economic stability is necessary for the shift from the use of conventional energy resources for the electricity generation to the non-conventional or the renewable sources. So economic stability needs to be considered. Are the people of the country able to afford this whole transition? Is the country itself is able to support financially this whole transition? It is economically stable to do so. So this factor needs to be considered when you are shifting or towards the renewable energy sources in order to decarbonize your country. And obviously social aspects of transition and dilemmas uh, are very common. Some people, for example, I have been told that when sui gas came into Pakistan, the use of sui gas was has when the use of sui gas started, when Pakistan, mm, the people were reluctant to rely on it. They would say that it is dangerous for the health, it is dangerous for the health of the females, or it is dangerous for the health of the kids. So many people did not support the idea of using the natural gas, to support the of using the natural gas in the kitchens or for the energy purposes. So they negated the idea. So social aspects of the transition and dilemmas are necessary to be considered, and these are the major challenges that need to overcome in order to decarbonize your area, in order to decarbonize your country, in order to decarbonize uh, globally by by shifting towards the renewable energy resources. Okay. And some of the important terms also are discussed usually when we talk about challenges to the decarbonization. Number one is the carbon bubble. It is a term that refers to over evaluation of the fossil fuel assets, such as oil, coal, natural gas reserve, due to the assumptions that all known reserves will be burned and the emission released in the atmosphere. Now, when we talk about the amount of carbon dioxide, for instance, released into the atmosphere, the term carbon bubble actually is useful, because when we consider that, for example, by 2050, this amount of carbon dioxide would be present in the atmosphere, so we are actually referring that all of the fossil fuel assets would be used by the 2050, and this much amount of the carbon dioxide would be present in the atmosphere by 2050. So this is actually over evaluating the whole concept. There is a chance that all of the fossil fuels are not used by 2050. Maybe a new technology is developed and the remaining fossil fuel would not be used. So this would obviously it is making the situation more alarming, right? That over evaluating the use of fossil fuel, over evaluating the whole amount of carbon dioxide present in the future, right? The second one is double counting. It's actually the is in the concept in the decarbonization. It refers to the potential for the same emission reduction to be claimed by multiple entities. For example, a company or organization is claiming that they are reducing this much amount of carbon dioxide in their processes. The same claim can be made by another entity, another organization, or another business initiative. This is called double counting. So that leads to inaccuracies in the emission accounting. For example, we would be, for example, if a company suggests that they have reduced their emission by 10, for example, a small organization is saying that they have reduced their carbon emission by 10 kilotons or 10,000 kilotons of carbon dioxide. And the same claim can be given by another organization who is actually not actively working on decreasing their carbon emissions. So it would lead to inaccuracies in the emission accounting, and obviously it would undermine the effectiveness of the climate mitigation efforts. That is, we would think that we are decreasing a more amount of carbon dioxide, but in reality, less amount of carbon dioxide mitigation is happening. And the third one is stranded assets. Stranded assets are those assets that at some point prior to the end of their economic life are no longer able to earn an economic return. That is, those assets that are present, but they are not before the end of their economic life, they're not able to earn the economic return. As I already mentioned, the term carbon bubble, that there is a chance that we are not using whole or every reservoir of fossil fuel or every asset of the fossil fuel, right? So this is related to that term. That is, those assets that we are calculating in our accounting, carbon accounting or GHG accounting, we are calculating there in order to make plan for the mitigation of the carbon dioxide or GHG mitigation, or to achieve a net zero target. There are chances that those assets are also included, that before the end of the economic life, they are no longer able to earn an economic return, that they are not being used or they are not giving us any profit. So these are the terms that need to be considered as well during discussion of the challenges to decarbonization. Now, related to this decarbonization concept, there is a guidance carbon calculator. It is called McKee carbon calculator, and it provides a model of the UK, United Kingdom energy system that allows its citizen to explore pathway to decarbonization. Using this calculator, the citizen can choose the levels of the ambition for decarbonizing different parts of the energy system. And then the calculator shows you the choices that would affect the country's emission, expressed as carbon dioxide equivalent. Its purpose is actually to help everyone, every citizen, every stakeholder engage in that debate. And it also allows government to explore how its plan support the path of the net zero, how the citizens are thinking of their activities towards the path of the net zero. I have given the link to this calculator. You can explore it by going to that link and check it out what type of other functions it have. When I will send you the presentations of today's session, you can just copy the link and paste it onto your browsers and check this calculator if you are interested. Now, related to this concept of net zero and carbon neutrality, there's a concept of green communication. It's actually environmental communication that explores the public perceptions of the real world and how they shape the relationship between the man and nature. Green communications are actually how the enterprises or the organizations or the firms or business are communicating with their customers, with their stakeholders, and how organization is processing that, how they would provide information, how they are communicating with the stakeholders about their commitment to the nature, about their commitment to the concept of net zero, concept of carbon neutrality to the consumer. So based on this green communication concept, many platforms or uh, uh, many platforms have derived various rules and given various key points that organizations should follow. For example, we have BCAP code. These are actually the advertisement on the radio central copy clearance. These are green claims actually published by the DEFRA and BIS. Those are Department of Environment, Food and Rural Affairs of the United Kingdom, and the Bank for International Settlements. These are actually the statements that are urging the advertisement companies or the organizations to take into account the rules and the rules, or is giving the guidance that they need to provide the green claims to their stakeholders in a way that, for example, the advertisement the organization is making to sell their products and services should make sure that the environmental claims they are putting forth are clear. Unqualified claims, misleading claims, or any omission of the significant information is actually detrimental, and this should not be done. All the terms they are using in the advertisement must be clear to the consumers. Absolute claims must be supported by high level of substantials or comparative claims. For example, if a company is saying that our product is greener or friendlier, it should be justified that how it is greener, how it is friendlier. It should be justified based on either scientific facts or either scientific data or any other, for example, certification. The environmental claim must be based on full life cycle of the advertised product. You cannot just say that our product is friendlier or green or environmental friendly when used. No, you have to consider the whole life cycle of the product. Other methods or other guidelines for the green communication includes the Green Claim Code. It's an organization that has organization or uh, a guideline uh, that gives that is urging the advertisement or the organization to give truthful and unambiguous claims. Obviously, as I already mentioned the previous one, that omission of important information is detrimental. It should not, the company should not do that. The comparison that they are giving, that our product is greener, our product is environmental friendly, that the comparison should be fair and it should be meaningland, and it should be based on the evidence and obviously full life cycle. We have ISO 14063 of environmental management system. It is related to the green communication as well. Obviously, it is also providing it also provides us guideline for general principle or policies, strategy, or activities related to organizations environmental communication. Either it is internal, either it is external. And then we have ICC framework, international uh, commerce framework for responsible environmental marketing and communication. Obviously, it is also pinpointing that their climate related claims, circulatory claim, and the additional free of claims, recyclability claim, degradable claims should be based on evidence, either scientific or either by the any certification body, and they should be given in a clear manner. Now, obviously, the whole concept of net zero is based on what we are actually adapting ourselves, our cities, our organizations, our country on the base, adapting to the climate change, because we have to live with it. Just not only mitigating the release of carbon dioxide or creating more sinks for the greenhouse gases is efficient or is enough. We need to also adapt our organizations, our living styles according to the changing climate as well, because the whole uh, process of net zero, the whole process of the carbon neutrality takes a long period of time. So what sort of technological trends can we consider or are being considered for the climate change adaptation? They includes, like for example, early warning systems. For example, we have tsunami warning systems, we have uh, rain warning system. There are also fire alarms, the systems prior to the impending danger, prior to these tsunami, for example, or wildlife fires. They give us warning prior to the events happening, so that they can give, or the countries or the area or the management can give a warning to the local people, and can take necessary steps to reduce or to minimize the effects of all these natural phenomena. Then climate resilient infrastructures, like for example permeable pavements, we have concrete, right? These are actually impermeable. So the permeable pavement would allow the rainwater to infiltrate the ground, reducing the surface runoff and flooding. And also it would also help us increasing the level of the water tables. Also, the concept of green roofs, like a vegetative roof system that absorb and retain the rainwater. They reduce the runoff and also insulate the buildings. Then we have nature-based solutions as well. For example, the wetland restoration and conservation, and adopting agroforestry and sustainable agriculture by using instead of using, for example, instead of using the chemical pesticides, you can use the biological pesticides. Then obviously water management technologies and agriculture adaptation technology, water management technologies, like for example rainwater harvesting, for example desalination, like wastewater treatments, stormwater management, etc. Agriculture adaptation would include drip irrigation, would include developing drought resistant crops, soil conservation practices, uh, etc. And obviously, we would need the climate resilient energy system as well, like hardening your power grids against storms, diversifying the energy sources to reduce the vulnerability. For instance, as I already mentioned, that renewable resources are intermittent, right? So diversifying these renewable sources, that not only relying on the single source of energy, you have to diversify, you have to establish many different sources of energy, so that in case one fails, the other would uh, somewhat uh, run and would uh, give the or would fulfill the demands of the people. But obviously, just like other new things or other development processes or other scientific developments, these technological trends for the climate change adaptation also have different barriers. For example, we have geographical barrier, like for example, uh, the regions where sunlight is not much available, where their solar systems obviously would not work much. Or there could be the presence of limited access to the resources. For example, isolated communities may face challenges in accessing essential resources like food, water, energy, etc. Or maybe some ecosystem must maybe there are fragile ecosystem, for example coral reefs, mangroves, etc., polar regions, where these technological trends would not be able to help much. Then we have also the cultural barriers as well. Language communication, there could be a barriers of communication gaps between the policymakers, scientists, and the local communities, obviously would hinder the or impede the effective collaboration. For example, if we are going to install drip irrigation systems, so the language barrier or ethical barrier, all the conceptual barrier, traditional practices would impede or hinder the collaboration between the policymaker. For example, in Pakistan, if you go to a farmer to introduce a drip irrigation system, maybe he would not be able to understand. He is not unable to understand the concept of drip irrigation and refuse to do so, right? So this is also a barrier where you cannot just force the people to adopt out a particular trend for the climate change adaptation. Obviously, there are political barrier that maybe uh, one political party isn't interested, that we see always see in Pakistan, for example, that the strategies made by one political party or one government are negated by the other. So all those barriers need to be considered in order to adapt to the technological trends for the climate change adaptation. And the whole concept, the whole process is not as easy as it seems. Now, there's another concept related to the concept of net zero or our transition to carbon neutrality, is the concept of geoengineering. It is a set of emerging technologies that could manipulate the environment and partially offset some of the impacts of the climate change. And it is divided into two broad categories. Number one is carbon dioxide removal or CDR, and the other one is solar geoengineering, also known as solar radiation management, SRM. The concept of carbon dioxide removal includes, for example, afforestation and reforestation, right? Nothing can be better than acting as a sink, better than the nature itself, because our nature, as I already mentioned at the start of this session, that the nature acted since the beginning, has acted as a source of sink for all the disturbances in the earth system, right? For example, our oceans, our trees are acting as a sink for the carbon dioxide. So by the reforestation or by planting many trees, would aid the absorption of the carbon dioxide for the atmosphere, and it would store it in the form of biomass, in the soil, in the roots of the trees, in the leaves of the trees. So this is how the carbon dioxide can be removed. This is one of the concept present in the geoengineering. Then we can also, there's another concept of bioenergy with the carbon capture and storage, like producing energy from the biomass crops, capturing the resulting carbon dioxide emission from the permanent storage underground. You can see various technologies, various researches going on in this concept, like, for example, producing a catalyst that can convert the carbon dioxide captured from the air into fuel, like ethanol, like formic acid, or like methanol, that can be used to produce energy, or various other chemicals. Then we have also direct air capture, DAC, where chemical processes capture the carbon dioxide directly from the air and store it underground, or we can utilize this for the other purpose. So these are the geoengineering, some of the examples of the carbon geoengineering or the carbon dioxide removal. Next is the solar radiation management, that is SRM. It includes, for example, technology or the strategy of stratospheric aerosol injection. Now, stratosphere is where our planes fly in easy terms, right? So injecting reflective aerosol, for example, sulfur dioxide particles into the atmosphere in the stratosphere, helps scattering of the sunlight, and which would ultimately reduce the amount of solar radiation that is reaching the Earth's surface. So that will help cooling of the Earth's atmosphere or the Earth's climate. Also, there's a concept of marine cloud brightening. Here, seawater can be sprayed into the marine clouds, like the clouds present over the seas or oceans, that would enhance their reflectivity and increase the amount of sunlight reflects back into the space. Instead of absorbing the amount of sunlight, absorbing all the radiations, this marine cloud brightening would aid the reflectance, more reflectance of the sunlight into the atmosphere, obviously reducing the warming of the oceans. Then there is another concept called as surface albedo modification. It also increases the reflectivity, but of land surface, of lithosphere. For example, painting the roofs white or planting reflective crops to reduce the absorption of the solar radiation by the earth. In this way, the whole surface of the earth would absorb less heat, hence cooling the whole environment. Now, obviously, just like any other technology, the concept of geoengineering, the concept presented by the geoengineering also have their risk, also have consequences. For example, we have environmental risk, for example, unintended consequences, that if we are altering the reflectivity of the Earth's surface or atmosphere, it could disturb the natural weather pattern and lead to drought, lead to flood or other extreme natural events, obviously. Or, for example, uh, if we are using a carbon sequestration method, for example, and using ocean fertilization, or giving a chemical into aiding, giving a chemical or throwing chemicals into the ocean in order to increase or enhance the carbon sequestration or carbon storing capacity of the ocean, it could cause ocean acidification because the ocean would then take more carbon dioxide than their original or their natural capacity. It would obviously result in the acidification of the oceans. That is, bicarbonate ions would convert into carbonic acid, so it would decrease the pH of the ocean, which would obviously affect the marine life. And also, injecting aerosols into the stratosphere, as I already mentioned, for example, sulfur dioxide into the stratosphere to reflect the sunlight, it could potentially deplete the ozone layer. And depleting the ozone layer has major consequences, as you already are aware. That is, increased amount of ultraviolet radiation reaching the earth, and obviously risking the lives and the health of the human beings. Then we have societal risk as well, like ethical concerns. uh, for example, this geoengineering may cause intergenerational injustice, or cause problems in equity, or help, or unequal distribution of the, it would cause unequal distribution of the risk, right? Some areas of the earth would be more affected as compared to some areas, so that would cause a societal disturbances, or would cause societal disruption. Okay. And also dependency and moral hazard, that is that if we are, for example, utilizing all these geoengineering concepts or technologies, it would also it could potentially make investors or the organization relying 100% or 90% on these technologies as compared to their own efforts to reduce the greenhouse gases emissions that we have already discussed, like decarbonizing, carbon sequestering, etc. So they would depend overall or wholly solely on these geoengineering technologies, would obviously negate and undermine the efforts of their decarbonization. So this is also detrimental, right? Uh, then we have technological risk as well, because many geoengineering techniques are still in experimental or theoretical stages. Obviously, they require more development and refinement before they can be implemented uh, at practical level. And also, there are chances that these technologies could be used for the manipulation of the Earth's climate system, or could cause any accidental or intentional misuse. For example, using some entities or organizations, rogue organization might use these technology without international oversight or consensus, which cause a geopolitical tension or conflicts, obviously. And we have governance risk as well, because geopolitical concerns are always present when a new technological development is established or come forward. So these were the major areas that we discussed in this whole advanced principles of the net zero. If you have any questions you need to ask, you can ask me. Righty, I think there are no questions you need to ask. Just in case, I will be sharing this whole presentation or the PDF of today's session. There are links to different sources that I prepared this lecture from, and I also will be sharing the PDF files. If you have interest, if you want to further study this whole concept in detail, you can use those sources to study or to inform yourself. Have a nice evening. Allah Hafiz.
Allah Hafiz.